Good morning. So today we are going to be using our solubility knowledge from yesterday and applying that to solubility curves. So yesterday we talked about solubility being the ability of one thing to dissolve in another, or the ability of a solute to dissolve in a solvent. So our tool to being able to see how much can dissolve exactly is going to be our solubility curve. And if you look at this graph, you have the solubility curve for a number of different ionic compounds. So the solubility curve is going to tell us how much can dissolve at a certain temperature. So for instance, if we look at our KClO3 line right here, we can see at 70 degrees, about 30 grams of KClO3 will dissolve. Okay? So no chemistry knowledge is needed in reading this graph. All you need to do is look at your axes. So we can see on our y-axis, we have our solubility, or in other words, the grams of salt in 100 grams of H2O. H2O is typically going to be our solvent when we're looking at these solubility curves. So we can see for KClO3, for instance, that 30 grams will dissolve in 100 grams of water. And on our x-axis then is going to be our temperature. So go down here, go to 70 degrees, and we're right there. So if we look at this, we can see that for most ionic compounds, their solubility in H2O, or water, is going to increase as the temperature increases. And you can see that with those positive slopes. You are going to have some exceptions, though, with such as the cesium sulfate down at the bottom. We can see there that this compound has a negative slope, or its solubility is going to decrease as temperature increases. Okay? So when we're reading this graph, if we're looking at the line, that means our solution is saturated. That means we've dissolved as much as we possibly can. So going back to our earlier example, at 70 degrees, a saturated solution of KClO3 would contain 30 grams of solute, or 30 grams of that KClO3. Okay? However, if we have less than that, if we have, say, 10 grams, that's going to be unsaturated because we can dissolve up to 30. Okay? So if you have anything beneath that line, that's going to be considered unsaturated because we can dissolve more. On the flip of that, let's say we were able to get 60 grams of KClO3 to dissolve. That's more than we would expect, more than our 30 grams. So that would be considered supersaturated. Okay? All right, so let's look at this example then. Here we're trying to find how many grams of KClO3 are needed to produce a saturated solution in 100 grams of water at 80 degrees Celsius. So we're going to come over to our solubility curves, go over to 80 degrees. We know we want to be saturated, so we're going to find at what point that line of KClO3 crosses 80 degrees. And we're going to see that to be right here. All right? So we can say about 38 grams of KClO3 will dissolve per 100 grams of H2O at 80 degrees Celsius. And again, we got that just by taking our x-axis as temperature. We know we want to find 80 degrees Celsius. So we find 80 degrees, go up to where it hits the line, and we find that to be about 37, 38. Okay? So at 80 degrees Celsius, we would need 38 grams of KClO3 per 100 grams of H2O. So if you look at this, the way I've written it is very similar to conversion factors. In fact, this whole graph is going to be conversion factors. Okay. So let's see how we would use this in our next problem. So let's say we wanted to find how many grams of KClO3 can dissolve in 40 milliliters of water at 80 degrees Celsius. All right, so first, we want to see how many grams of KClO3 would dissolve in 100 grams of water at 80 degrees Celsius. So just want to read our graph. So if we look at 80 degrees, we said about 38 grams of KClO3 could dissolve per 100 grams of H2O. Okay, so we want to find out how much can dissolve in 40 milliliters of water. Right now, all I have is grams, and this question is looking for milliliters. But we know from our first unit that the density of water is equal to 1 gram per milliliter. So if we have 40 milliliters, that's the same as how many grams? 40, right? Because 1 milliliter is equal to 1 gram. So here, we're trying to find how many grams of KClO3 can dissolve in 40 grams of water. Okay? Now, we can do our conversion factor. So if we start with 40 grams of H2O, put that over 1, and multiply that by 38 grams of KClO3 over 100 grams of water, we'll find how much KClO3 can dissolve in that 40 grams. We have grams of H2O on top, grams of H2O on bottom, so those cancel. So we'll take our 40 times 38 divided by 100 and find that we can dissolve 15.2 grams of KClO3. Okay. And that answer makes sense, right? Because if we have less water, we would expect that we can only dissolve a smaller amount of solute. So again, you can use the data from the solubility curve as a conversion factor. Okay? And using the fact that the density of water is 1 gram per milliliter, we were able to find how many grams of KClO3 we could dissolve in 40 milliliters or 40 grams of water. All right, let's look at a different type of problem. Here, we're looking at the saturation of lead nitrate at 20 degrees Celsius. And we want to determine if we have 40 grams of this, is that solution unsaturated, saturated, or supersaturated? So in order to know this, we first need to find how many grams of lead 2 nitrate we need to make a saturated solution. So again, we start with our x-axis. We're looking at 20 degrees Celsius. So we come over to 20 degrees Celsius and go up to our lead nitrate. And we find that at 20 degrees Celsius, we can dissolve we can dissolve about 58 grams of lead nitrate. All right, so if we have 40 grams of lead nitrate, is that more or less than that 58? It's going to be less. Since 40 grams is less than the 58 grams needed to make a saturated solution, this solution would be considered unsaturated. Because we haven't quite yet hit that saturation value of 58 grams at 20 degrees Celsius. Right now, we're sitting down here. So we're below the line. So it's going to be an unsaturated solution. If we wanted to find how much more we could dissolve, we're at 40 grams. We can dissolve up to 58. So that means we can dissolve a total of 18 more grams before we get that saturated solution. Okay, so here we have the same idea. Oops, I already answered this one, but let's go through it again. So here we were saying we had 40 grams of PbNO3 at 20 degrees Celsius. So we're sitting right here. But we said that we could dissolve up to 58. So we can dissolve this much more. So in order to make a saturated solution, we need 58 grams. We only have 40 grams. So we can dissolve a total of 18 grams more of PbNO3. Okay. Again, that's because we have 18 grams less than what we need to make a saturated solution. All right, so here we have a supersaturated solution of KCl. So we go to our KCl line. We're saying that we're at 70 degrees Celsius and we have 60 grams of KCl. So we're sitting up here. Again, since we're above that line, we're above our saturation amount. This is going to be a supersaturated solution. Okay? So this question is finding if our solution becomes saturated, so some of our KCl comes out of solution, how many grams of KCl will come out of solution in order to become saturated? So right now, we're sitting at 60 grams. And if we look at our line, KCl can dissolve about, let's say that's 49 grams of KCl per 100 grams of water for a saturated solution. All right, so then if we're trying to find how much will come out of that solution, if we're at 60 grams, we're going to take our 60, so how much we have, and subtract that 49 grams. That's how much we can have in solution for it to be saturated. So we do 60 minus 49, and we find that 11 grams of KCl will come out of solution. And what that means is we're going to get this layer of solid KCl at the bottom of our beaker. Okay? That 11 grams will no longer be dissolved in our solution. So if we have a supersaturated solution at 60 grams, and at 70 degrees, our saturated value is about 49 grams. If we become saturated, 11 grams have to come out of solution and kind of settle at the bottom in order to reach that number.